Okay guys, welcome back. So in the last video I talked about how to calculate the frictional force and the net acceleration when given some force in an inclined direction. So for the whole example, for the total number of examples I have been talking so far, what I have discussed is that the force or the object is been kept on a horizontal plane. Now you can't possibly keep an object in a vertical plane. So what it actually happens is, in this video is I will be talking about an object in which it is kept on, actually the object is kept on an inclined plane. Now what happens to an object when it is kept on an inclined plane? Alright, I'll take the same object, right? I'll take an inclined plane like this. Its inclination to be say 30 degrees, and the object is kept on this inclined plane, and this object, the inclined plane to be frictional, right? And the object's mass is 10 kilograms as before. So now 10G will be acting straight down from the center of gravity, right? So I'll put a force of say 60 newtons. 60 newtons upwards. Now this is up, parallel to the inclined plane, right? Parallel to the inclined plane, upwards parallel to the inclined plane. And what I am asking, what is the acceleration? What is asking is, what is the acceleration of this object, right? So I'll take mu equals 0.4 here. Mu equals 0.4. So first of all, before calculating the acceleration, as in the last videos I talked about forces when you are given some inclined forces, what happens to the object. So in this video also, what actually happens is that we have to actually draw the forces, what is actually happening to this, draw the forces that are acting on this object. Now you have been given that this inclination is 30 degrees. Now we have to actually draw the other forces that are acting on this object. Now if this was kept on a horizontal plane, the only force that is acting on this object, regardless of the friction and the applied force, is that the value of gravity and the normal force, right? So in this example, you have to derive some more forces. We have to actually decompose the forces in some directions. So we'll talk about it. So the frictional force, now the normal force, as I mentioned before, whether it's inclined or horizontal or in any other direction, the normal force is perpendicular to both surfaces. So this surface is actually parallel to this surface. So the normal force is now not vertical. This is although the weight is vertical, the normal force is not vertical. The normal force is perpendicular to the surface. Normal force need not to be vertical, or the normal force need not to be angular. So what it actually happens, if you keep it on some surface, whether it's horizontal or inclined, the normal force is actually perpendicular to the surface, not perpendicular to the horizontal or not vertical. It is perpendicular to the surfaces, to two surfaces. So two surfaces are parallel, so it will be perpendicular to both surfaces. And what it actually means is the normal force should go through its center of gravity as well to keep this object. It should go through the center of gravity, right? So the normal force will be like this. We'll take this as R, right? It is now perpendicular to this surface, not perpendicular to the horizontal, not perpendicular to the horizontal or not vertical. That means not vertical. It is perpendicular to this surface. All right. So that's R. All right. So I have taken this surface as frictional. So I have to calculate the frictional force. Now what it actually happens is that if this object were given some force in this direction, the actual object's actual motion will be in this direction, right? So to oppose that motion, the frictional force is always acting so as to oppose the motion of this object. So to oppose this motion, what should actually happen is that the frictional force should be in the other direction. So if the initial applied force is in this direction, the frictional force is in this direction. So the frictional force I will draw here, Ff. Alright. So those are the only forces if you are drawing on a horizontal plane. Now what happens if you are kept on, now this object has been kept on a vertical plane. Now the weight is vertical, but you can decompose the weight into its components. Now, you cannot decompose it in the horizontal direction. What it actually happens is that now you can decompose the weight in the direction that is parallel to the parallel to the inclined plane and perpendicular to the inclined plane. So that will be a great advantage if you are decomposing that before starting the sum. So that will be easy for you if you draw all the forces. So what I'll actually do is I'll decompose this force into its two components, one along the inclined plane and the other that is perpendicular to the inclined plane. So I'll say now this angle is 30 degrees. So I'll draw perpendicular here. So this angle will be 30, and the component or the composition of the decomposed force of gravity or the weight along the inclined plane will be 10g sine 30. 10g sine 30, and the force that is perpendicular to the plane will be 10g cos 30. So these are actually not needed if you are well versed in the subject. So these it will be easy actually, right? You will not mislead when you are solving the sum. It will be easy if you are drawing this. So now this seems to be a very complex free body diagram or a force diagram of the subject. Now I will separate the subject from this plane, right, and I will draw it separately. Now this is the object I have been talking about so far, right? So the applied force is 6 newtons this direction. If I put a force 6 newtons, if you are pulling or pushing an object, it's the same. Actually, what is needed is the direction of the force, not whether it is pulled or pushed. So the direction of the force is this direction. So to avoid complex scenarios, I have drawn this force this direction. In this direction, so the friction force will be in this direction, Ff. The composition of the gravity in the direction of the direction parallel to the inclined plane is in this direction, so that will be found 10g sine 30. So I'll take g equals 10. I'll take g equals 10. So if g is equal to 10, 10g will be 100. Sine 30 is half, so 10g sine 30 will be 50 newtons. 50. And so this is the value. R is perpendicular to this object, so I'll draw it from here. R is perpendicular, and the value of R with the direction of R is actually equal and opposite to 10g cos 30. So the 10g cos 30 force will be in this direction. G cos 30. Now what I want here is that I have been given mu equals 0.4. So the question is asking what is the value of A. So I'll take the direction of A positive in this direction and A negative down the slope, A positive up the slope and A negative down the slope, right? So what I'm asking is what is the value of A. Alright. So to find the value of A, I need to find the value of R. So if I put F equals MA in a direction that is perpendicular to this plane, I can find the value of R. F equals MA in the direction that is perpendicular, right? This is 30 degrees and that is perpendicular, right? So R will be positive if I take this direction as positive. So R will be positive and 10g cos 30 will be negative. So this is minus 10g cos 30. And its acceleration I will take as 0. Object is not accelerating in a direction that is perpendicular to its plane. So if this is 0, R will be 10g cos 30. So I will write it directly. So g is 10, right? G is 10 meters per square second. So 10g is 100. Cos 30 is root 3 by 2. So 100 times root 3 by 2 is 50 root 3. So R will be 50 root 3. Right? R will be 50 root 3 and its force is Newton. Right? So if R is 50 root 3 and if an R are positive, so you can find if FF equals mu R. So that's the maximum force, right? Maximum frictional force. So mu has been given as 0.4 and R is equal to 50 root 3. So the frictional force will be 50 times 0.4 times root 3, which will be 20 root 3. Right? 20 root 3 newtons. 20 root 3 newtons. So that's the frictional force. So the frictional force is 20 root 3. So root 3 is actually equal to 1.732, I think. I hope so, right? 1.732. So the frictional force will be 20 times root 1.7, that will be about 34 newtons. So this is approximately equal to 34 newtons. Right? 34 newtons. So the total force in this direction, if I consider this object again, right? If I consider this object again, the total force in this direction will be 34 newtons. Now I have FF as 34 newtons and I have another 50 because due to the weight's decomposition in this direction. So the total force down the slope will be 50 plus 34, which is 84 newtons. 84 newtons. And the total force I applied, which is opposing to both these forces, is 60 newtons. Right? So the total applied force is less than the total force that is actually opposing. Now the weight's decomposition in a direction that is horizontal, not horizontal, weight's decomposition in a direction that is parallel to the inclined plane is also now opposing the object's motion. Not only the friction, the weight's decomposition is also opposing now. So this total opposing force is 84 newtons, total favorable force will be 60 newtons, so the opposing force will be greater than the favorable force, so the object's acceleration is actually 0. As I mentioned, even though the frictional force is greater than the applied force, the object will not accelerate in the direction of the frictional force, so the object will not accelerate downwards, so the total, so the net force is 0. And net force is not 0, net force is some value, but the object will not accelerate in that direction. So the acceleration of the object will be recorded as 0. So in this example, I do an object which is on an inclined plane, and what happens to this object when I increase the force and if I put some force on that object, how will that object accelerate on the plane? Now if I put a force of greater than 84 newtons, say Newton 90 Newton or something like that, that force, the favorable force will be greater than the opposing force, so the object will accelerate up the plane. So this is a simple video, in a simple example I talked about in this video as to how an object will behave when it is on an inclined plane. So in the next videos I will be talking about more complex problems. So thanks for watching this video and see you then.